Hi dear students, welcome to my channel. In this video what we discuss is rigid body rotation about a axis. First I will tell what is a rigid body. Rigid body means simply very simple. You see this. I am trying to compress it. I am compressing hardly but still it is not compressing. So I can say it is a rigid body. Okay. So for the definition, what I want to say, rigid body means it is non-deformable. Means when you are pressing, it is not deforming. The shape remains same. So I can call it as a rigid body. You may ask some question. I will compress very hard. Then what happens? Okay, it will break. That is a different thing. So for the definition, rigid body means simply you assume non-deformable. Okay, and distance between any two particles of the body remains constant. Suppose this object, you take one point here, one point here. These 2 points distance will not change even though you are compressing it. That time only we are calling a rigid body. Okay, it is simple. We are assuming rigid body means it is non-deformable and the distance between any two particles in the body remains constant. That is our rigid body. Now you understood what is a rigid body. Okay. Now what is a rotation? And what are the things we have to understand in this video? Rotation means, first I will tell you, linear motion, one object is moving like this, straight line. Rotation means one object is rotating about a fixed point. You see here, this is a reference line. This is a reference line. Okay. So this reference line, this object is rotating like this, rotating like this, rotating like this. Okay. This rigid body is rotating like this. Okay. First I will introduce what is angle. What is angular position? Initially both are along the straight line. So after some time it is rotating like this. No, it made some angle. So this pen made some angle with this scale. So this is angular position. Okay. Now angular displacement we talk. Angular displacement means what is the initial angular position. Suppose initially it is 30 degrees. After sometimes it has gone like this. This is 60. Suppose this is 60. This is 30. So initially it is 30 degrees. Okay. So after some time it is moved to 60 degrees. So initially 30 degrees. Now it is 60 degree. What is the change in angle? 60 minus 30, that is 30 degrees. So that is called angular displacement. Means final angular position minus initial angular position. Angular position means simply theta, angle. Okay. So that is angular displacement. Now I discuss angular velocity. Angular velocity means angular displacement per unit time. Means it is rotating some angle from here to here. How much time it has taken? Angular displacement divided by time is called angular velocity. Okay? Or angular speed, whatever you call. Now this angular velocity also may changes with time. Suppose from here to here it has taken some 2 seconds. Here to here 1 second. Means angular velocities keep on changing. Means it is slowly rotating and fast rotating. Okay, slowly rotating then fast rotating. So angular velocity also changing. So change in angular velocity divided by time interval, that is angular acceleration. Simple velocity, rate of change of displacement, acceleration, rate of change of velocity. Similarly in rotation motion also, angular velocity means rate of change of angular displacement. Angular acceleration means rate of change of angular velocity. This all will discuss in this video. Keep watch forward, you will understand very clearly. This is class number 97. Rotation of a rigid object about a fixed axis. First we discuss what is a rigid object. We are defining like this. Rigid object means it is non-deformable. distance between any two particles of the object remains constant. For this condition only we are calling that is a rigid object. Okay. Now we go for angular position. What is meant by angular position? That we discuss now. See here, angular position is simple. This is a reference line. So now it is rotating. Suppose my pen is rotating like this. So it has rotated some angle with respect to reference line. This is a reference line I am taking. With respect to this pen is rotated to here. So it is rotated some angle theta. This theta is angular position. For this angle, if you go along like this, you will get this point. So this theta is angular position theta. Okay. What is this distance OP? I am calling OP. That is R I am calling, because it's just like you are going to draw a circle. You are going to draw a circle. No? So this OP equal to R. This arc, this curved path, S, arc length, and angular position theta, and radius of this curved path R, related like this. This S is equal to R into theta. S is equal to R theta. This formula you remember. Then theta equal to S by R. Theta is dimensionless because length by length. So theta equal to arc length divided by radius of the curvature, radius of the arc. So theta equal to arc length divided by radius of arc. Okay. Unit of theta is radian, RAD. Okay. This actually degrees, 20 degrees, 30 degrees, 40 degrees, 60 degrees also we talk, no? So how to convert particular angular position into the radians like this? Suppose theta is some value 60 degrees. That 60 degrees convert into radians. For that what we have to do? Pi divided by 180 into theta. Pi is some value. It is one number 22 by 7. Okay. So pi divided by 180 into theta. Theta in degrees. So you are converting angle into radians. For that what you have to do? Pi divided by 180 into theta in degrees. Example, theta equals 60 degree. I want to convert into radians. How? Pi by 180 into 60. Pi by 3 radian. So 60 degrees equal to pi by 3 radian. Okay. Why we have to convert degrees into radians? Suppose S is length of the arc. So theta must be in radians to find out the length of the arc. That is why you have to convert degrees into radians. Then only you will get this S value, that is length of the arc. Suppose 60 degrees, R into 60 degree you should not write. Instead of 60 degree you write pi by 3. Pi value is given 22 by 7, that is 3.14. So you can get this arc length. Got it? Angular displacement del theta. Linear displacement means one particle is traveling along a straight line. Here angular displacement means it is rotating. For that we are calculating angular displacement. See here, very simple. I am taking a reference frame, XY frame, X axis and Y axis, this is origin. Here one particle is moving like this from here to here, or one stick is rotating like this. You assume it is a stick, it is rotating like this. So initially it is rotated from here. It is exactly along the x-axis. So after some time it has come here. So it has made some angle theta I, initial angle with the x-axis. It is a reference line. So initial angular position is at P here at initial time Ti. After time T, Tf, from Ti to Tf, after some different time, it is keep on rotating, no? It has come here. that particle or this stick is rotated here, from here to here. So how much angle? Theta f. With respect to x-axis, it is rotated up to here. So it is moved in angle by theta f. Initially it was at theta I. So final angle minus initial angle, that is del theta, equal to theta f minus theta I. We want angular displacement, no, this only angular displacement. Final angular position minus initial angular position, that is called angular displacement. Linear displacement, final position minus initial position. Here final angular position theta f minus initial angular position theta I. This is called angular displacement. If you know the angular displacement, you can find out the angular velocity also, angular speed also. Angular speed means angular displacement divided by total time taken. That is this angular speed omega equal to angular displacement theta f minus theta I divided by total time interval tf minus ti. So time taken to make angular displacement, that is tf minus ti. Simply theta f minus theta I by tf minus ti, that is del theta divided by del t. This is angular speed, average angular speed, that is angular displacement by total time taken. Okay. Instantaneous angular speed omega. Instantaneous means, suppose it is rotating like this fast, no? Rotating like this. Suppose this pen you see, it is rotating like this fast. At some instant it is here. At some instant here. At some instant it is here. At some instant it is here. So that instant, what is the angular speed? At some small time interval. Small time interval, what is the angular speed? That is called instantaneous angular speed. I am using a letter omega for this. This omega equal to limit del t tending to 0 del theta divided by del t. Means for a small time interval, I told, no? It is rotating like this. At some time, maybe here or here or here. For a small time interval, at particular time I can call. What is the angular speed? That is called instantaneous angular speed. So it will become like this, d theta by dt. Limit del t tending to 0 del theta by del t equal to d theta by dt. The unit is like this, radian per second. For angle, unit is radian, you know, time second. So unit of average angular speed or instantaneous angular speed, the unit is same only, radian per second. Okay. Now we discuss average angular acceleration. Means, you know, general acceleration, linear acceleration, speed is increasing continuously. Similarly, here angular speed is increasing. Means initially rotating slowly, it is rotating very fast. Slowly rotating, very fast rotating. Means the angle is changing, or omega, angular velocity or angular speed is changing very fast. Angular speed is not constant. Angular speed itself is increasing or changing. That time we have to go for angular acceleration. Average angular acceleration, I am using a letter alpha. Alpha bar means it is average. Alpha bar equal to final angular speed minus initial angular speed. So omega f minus omega I by tf minus ti. This is time interval. So del omega by del t, that is called average angular acceleration. Unit is simply radian per second square. You got it? By using this all formulas, we can solve some problems. you will understand very clearly how to use the formulas and solve the problems. Okay? Please like this video, share this video and subscribe my channel. Thank you.